The question says the set of values of x satisfying mod of sin inverse x less than equal to mod of cos inverse x is. Now we know that cos inverse x belongs to 0 to pi. Therefore, the value of cos inverse x is always positive. So we can write mod of cos inverse of x as cos inverse of x. Now we have sin inverse of x mod, which is equal to sin inverse of x when x belongs to 0 to 1, and it is equal to minus of sin inverse of x when x belongs to minus 1 to 0. Now let's take the first case when x belongs to minus 1 to 0. Now in this case, mod of sin inverse x is equal to minus sin inverse x. Therefore, minus sin inverse of x is less than equal to cos inverse of x. So this will give sin inverse of x plus cos inverse of x greater than equal to 0. And this is equal to pi by 2. Therefore, pi by 2 is always greater than equals to 0. So this is the complete answer. That means for all these values, this inequality will always hold. Now the second case, when x belongs to 0 to 1. Now in this case, the inequality will become sin inverse of x is less than equal to cos inverse of x, and this will give sin inverse of x less than equal to pi by 2 minus sin inverse of x, and this will give sin inverse of x less than equal to pi by 4, and from this we can write x less than equal to 1 upon root 2. Now we know that x is in between 0 to 1, and from this we are getting x less than equal to 1 by root 2. So the intersection will give x belong to 0 to 1 by root 2. Now combining the result for the first case and the second case and taking their union, we get x belong to minus 1 to 1 by root 2. So this is our answer. So we can see option 1 is the correct answer. Let's check. Yes, 1 is the correct answer. Thank you.